Before solving the problem involving the manipulation of fractions, let us take a look at two processes that have the potential to shorten our work. The first one is to write a mixed number as an improper fraction. And in order to do that, we label the whole number, the numerator, and also the denominator. And of course, we have a key here, which is the list, telling you that the W is for the whole number, N is numerator, D is the denominator. The mixed number will have the format dW plus N over D, which is not so sophisticated. Richard James does not like to have a lot of mathematical representation given purely in letters, because it just seems like a cumbersome formula to which there is no end to its simplification. But it is not. So we will take a look at what that means when we apply that to a literal mixed number, and that will be much clearer. Let's see how this works with a real mixed number. 4 and 1/5. 4 and 1/5. We will multiply the denominator by the whole number. That is our first part. The product of the denominator and the whole number. That's what we have right there. Then that will be added to the numerator. The result will finally be placed over the denominator. From now on, it is just a matter of simplification. 5 4s 20 plus 1 is 21, and that will be placed over the denominator. 5 4s 20 plus 1, 21, that is placed over the denominator. And that's all there is to it. The next process will be a quick look at an easy way to add fractions whose denominators do not have a common prime factor. If the denominators do not have a common prime factor, then we usually take this approach. Now, this approach is not limited to fractions that do not have a common prime factor in their denominators. But if the fractions have a common prime factor in their denominators, then the resulting fraction is not going to be in its simplest form. In that case, the denominator will still be the LCM of the denominators, but it will not be the product of the denominators. If the LCM of the denominators is equal to the product of the denominators, then it means that the denominators do not have a common prime factor. And that is the case in consideration in this audiovisual. The result will be comprised of 3 products. What are those products? The resulting denominator will be the product of the denominators. The common denominator is the product of the denominators. The first product of the numerator is the leading diagonal. There's a product, the first one, we will have 2 of them. The first one is the product of the leading diagonal. A times D, that goes there. Then we will have the product of the subordinate diagonal. The product of the subordinate diagonal, that one will go next. C times D. And that may be simplified if it were in numbers, regular numbers. And no doubt we will go straight ahead and see how that will work for a sum of fractions that is purely in numbers. So we have 2/5 plus 3/4. The resulting denominator will be 4 times 5, and that will result in 20. We will not simplify that just yet. What else? Then we will have the product of the leading diagonal. That will go next. Then the product of the subordinate diagonal will go next. Finally, we will simplify the result. So let us do that very quickly. The denominator is the product of the denominators. Then we have the leading diagonal going first. The subordinate diagonal will be next. And then, after that, it will be a matter of just simplifying the resulting arithmetic expression. 4 5s, 20, no doubt. Then we have 2 4s, 8. What is next? 5 3s, 15. And there's further simplification by adding the numbers in the numerator. 8 plus 15, that will give us 23. Maybe we will put the denominator first. Yes, the denominator goes first. And then we say the sum of the numbers in the numerator will go next. And that's all there is to it. So the result is 23 over 20. And that's all there is to it. Shortened versions of these processes will be used on the solution slides. It is best if you pay attention to this process and the one before, because in manipulating fractions, we will not have the luxury of going through all of this when we are solving an actual problem. Not just because of its cumbersome nature, but also because it might be time consuming. Additionally, it will not be completely necessary. Therefore, we imagine that this and the one that we have on the previous slide, that those two are already understood.
For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.